Okay, welcome to the 3M or grade 11 mixed University College level math, chapter 2 review, page 114, 115 from your text. Also, I have a word problem that I have from another source, which I'll describe right now anyway. So, apparently I should start with a joke. My last video has a thumb down, so I think I need to start with a joke. So here we go. What do you call a pig who knows kung fu? Again, what do you call a pig who knows kung fu? The answer is, wait for it, a pork chop. Thank you very much. A pork chop, kung fu pig. Okay, so 3M chapter 2 review. Let's talk. Let's do number 11 from our review page. You have a ball being thrown from a cliff. In the word question, h at t is equal to, and I've changed this. If you have the original copy of the review, it's a little different. I've changed this to 75. Okay. So h at t is minus 5t all squared, or 5t squared plus 10t plus 75. Somebody's throwing a ball off a cliff for some reason. A lot of math questions involve people throwing things off cliffs or lighthouses, which is a little bizarre. But there's my cliff. I've warned you guys before, do not feel bad that I draw so well compared to you. I'm highly trained. So here's your cliff. The ball is being thrown off the cliff. And the questions could be as follows. What is the height of the cliff? Well, this is standard form of a parabola or quadratic. And if that's standard form, then there's your c. You have ax squared plus bx plus c. There's your c. Your c is, in fact, the y-intercept. So the answer is the answer to what is the height of the cliff is also what is the y-intercept. Okay, so if this was xy and I had a parabola that looked like this, same sort of thing here. There's a y-intercept, and it's at 75 meters. And B, when does the ball hit the ground? Well, that is, looking over here, that is your zero. That's from here to here. That's one of your zeros. So to do that, what you're going to do is set your equation to equal to 0 and then solve. And you will look at this and originally look at it and say maybe that's a complex trinomial. But I noticed that that's a 5, that's a 10, that's a 75. They're all multiples of 5. So I'm going to see if I can get rid of this 5, and I can. And when I do that, I'm left with this as my trinomial in the bracket. So negative 5 bracket t squared minus 2t minus 15. And that's equal to 0 still. And then I will factor this trinomial, two numbers that multiply to negative 15 and add to negative 2. I know that that's a plus and a minus because they multiply to a negative. I also know, because this is a negative, that my larger of the two numbers is a negative. So what multiplies to negative 15? Well, negative 15 and 1, those do. But when I add those together, I get minus 14, so that's not it. How about negative 5 and 3? And when I add those together, that is correct. Okay, I get minus 2. So there are my factors, and from here I want to get my zeros. So I just changed the signs here. Minus 3 plus 5. And those are my zeros. So how does that make any sense? What is it? What are we looking at here? So that means that this here is plus. That's a positive t, so that's plus 5. This is my minus 3. So this is a backwards in time type of answer. It doesn't make any sense. So in real life, I'm just looking at the answers in what we call the first quadrant, okay, which is positive x, positive y normally, or in this case, positive t and positive h. So I only care about positive h's and positive t's because otherwise it doesn't make sense. Down here, I got negative h's, which is below ground question. So when does the ball hit 32 meters below the ground? Well, that usually doesn't make sense, right? Once it hits the ground, it's done. Over here, I have negative time, so that's a question like, how high is the ball at 62 seconds before I threw the ball? That doesn't make any sense either, right? And down here, you got a huge mess here. This is like living in it's horrible. It's like living in Sarnia down here. So this is horrible down here. So what we want is this area here, just a positive version. So this is what we call inadmissible. Not in general, but inadmissible according to the question itself. So this makes no sense. The negative 3, what have I done here? The negative 3 makes no sense in this question. We just want positive time. So the answer is, when does the ball hit the ground? The answer is 5. Okay? So that's that. The last question you might be asked is, what is the height, the maximum height of the ball? Oh, sorry. When does the ball hit its maximum height? Okay, and that question is, when do I get here? Here's my vertex. Okay, if I knew the vertex, which I will know, or I'll know part of it in a second, when does it reach its maximum height? And that is right through the axis of symmetry. So if you have a parabola, if you have a 0 and another 0, in between the two zeros is the middle, right? And in the middle is your vertex. Okay, so you want to ask yourself, when do you get here? And to do that, you take your two zeros, minus 3 and plus 5, so excuse the negative 3, and divide that by 2. So negative 3 plus 5 is plus 2, divide that by 2, and your answer is 1. So when do you reach this? Or when do you reach your maximum height? Or what is your h value when we looked at h and k as a vertex? Or what is my axis of symmetry? The answer to all that is negative, or plus 2 over 2, which is 1. Okay. Next page. How do I add pages? I always forget. Let's press. This is very exciting. Okay, so let's do the review now. So this is page 114 from your textbook. Which textbook is it? It's the Function Applications, McGraw-Hill, Ryerson. If you go to Beale, that's your textbook. If you don't go to Beale, I wonder why you're watching this. You must be looking for something else. Lupus math, L-U-P-U-S math, which would be the math concerning lupus disease, which is probably very fascinating stuff. Anyway, so let's look at this, page 114, number 1. I have this as my equation. I'm going to zip through this stuff. And I'm asked this, what form is that? Well, that's standard form, ax squared plus bx plus c. And questions could be, what is the y-intercept? And it's right here. The other questions, I think, here, another question could be, what's a? Well, a is what's in front of the x squared. In this case, it's 1. What's b? Well, that's here. That's 5. And what's c? That's negative 8. So the important ones are a, again. A gives you your step pattern. Okay, if it's positive, you open up. If it's negative, you open down. And then to sketch it, stretch or compress. That's all from the A. And from C, you get your y-intercept. So this guy here, sketch this guy here. What I have here. So that's that. What else do we have? Let's do some erasing. Okay, next up, I have, in question 2, I have negative, f of x is equal to, in question 2, I have negative x minus x minus 3, x plus 5, and I'm asked things like, what are the zeros? Well, what are the zeros? You got to change these signs, okay? Pull them out, change the signs, and how does that work? Well, if that was set to 0, okay, we set this equal to 0, that is, when does that equation here hit this line here, which is the line y equals 0. That's where you get the 0. So where does it hit the line? And to find that out, what you're going to do is, you have something times something, and the negative, it doesn't matter though, but something times something is equal to 0. Well, if you have two somethings that are multiplied by each other, if a times b is 0, then either a is 0 or b is 0. Or 0, 0. Or that's deep. Or a and b are 0. Okay, so you could have 0 times b, that's 0, or a times 0, that's 0, or 0 times 0, and that's 0. Okay, so one of these has to be 0, both of them. In this case, they both can't be 0, but so I have x minus 3 and x plus 5. So if this was equal to 0, if x minus 3 is equal to 0, that means x is equal to, solve for x is 3. So that would mean that I have 3 as my 0, or my root, or my x-intercept. So zeros, roots, x-intercepts, all the same thing, essentially, okay? What's my 0 from x plus 5? Well, that's going to be that number, but change the sign, so that's going to be over here at negative. And because this is negative, it's going to open down, so it's going to be something like that. Other questions, you might be asked, what's the axis of symmetry? That's like the question I just did on the word problem. You're going to take your two zeros of 3 and negative 5 and add them together. So your axis of symmetry here will be negative 1. And then you can sub that back in. I'll do this actually. Sub that back into this equation to figure out what what's going on here? Anyway, am I in charge here? Is it working? Okay, something weird happened. I'm not sure. Anyway, so let's ignore the last 5 minutes. I may have been abducted by aliens there. I don't know. Anyway, let's look at this and let's go back and let's say that our zeros were 3 and negative 5. I'm not even sure anymore what's going on. Yeah, that's right. So my zeros are 3 and negative 5. Divide that by 2 to find out that your H value, your axis symmetry, is negative 2 over 2, which is negative 1. So now if I want to find my K value, or my vertex, or the other part of the vertex, what I'm going to do is I'm going to sub this back in for x. So then I have negative, minus 1, minus 3, and minus 1 plus 5. And if you remember, what you're going to have in both brackets is the same number with different signs. So I have minus 3 minus 1 is minus 4, and that is 4. Minus times a minus is a plus. 4 times a 4 is a 16, so I end up with plus 16. So my vertex would be negative 1 and 16. Okay. That's your vertex. See how I put brackets? I don't know if you can. Well, then. Okay. Look at the brackets. Round bracket, comma between. That's the vertex. Don't do that with other things. So if my zeros were 3 and negative 5, okay, they're 3 and negative 5. They're not this though. Okay, that's the point 3 negative 5. So please don't put that. If I go to question 3, okay, we're zipping along here. If I go to question 3, I have y is equal to 2x minus 1 all squared minus 3, and this is vertex form. Remember, this is h and k in here, so what you get here, there's your a, you still get your step pattern from a, and your vertex is 1 plus 1, got to change that sign, minus 3. So there's your vertex. Axis symmetry is going to be x is equal to 1. The maximum, this guy opens up, so this guy here has a minimum, not a maximum. So it has a minimum, and the minimum is going to be this value here at negative 3. So what that, looking at this, if this was graphed on an x and y axis, there's your x, there's your y. And I do this at 1, negative 3, and I would have a minimum at negative 3. Okay, so that's the answers to those questions. What's the y-intercept? You would expand this whole thing. So let's do that real quick. X minus 1 all squared minus 3. So I'm going to square this. So x minus... I got this at the dollar store. It's got to be good. X minus 1 times x minus 1 times 2. Subtract 3. That's going to be 2 times... minus 2x. I'm going to do this one step. Plus 1 minus 3, which is 2x squared minus 4x plus 2 minus 3, which then is equal to 2x squared minus 4x minus 1. There's my c value. There is my y-intercept. So this sketch is actually I didn't know that. Sketch. It's down below. Okay, let's move on. And we'll go with a nice brown hue. I have the earth tones today for my colors. So I'm going to move on to 6A. Now I want to do 6A just because it's a simple question, okay? And what happens is a lot of times we do the hard questions, we forget the simple stuff. So if I'm asked this, or if you're asked this actually, what's going on with this question here, expand and simplify. Remember, open up a bracket. Okay, so this is an easy question. You could have done this in grade 9, but you may have forgotten how to do this because you're so busy right now. You can open that bracket up and multiply by what's in front of the bracket. So it's 2 times x, and that's 2 times 3. So that times that times that. 2x plus 6. 4 times x is 4x. 4 times minus 5 is minus 20. Like terms, x's, 2x and 4x, that's 6x. Equal signs there. Plus, oops, what's that x? 6 minus 20 is minus 14. So I'm all done. Okay, simple. Super simple. Just don't forget those easy ones on tests. Okay, so 10A. Next up, I have this y squared y 20. So you look at this here, you say to yourself, does 3 go into 20? No, it doesn't. Does 4? negative and positive. I interchange them. Some people are really anal about not doing that. Okay, 11a. Factor, but you can always look to common factor. That looks like a complex trinomial, but it's not, because what's going to happen is okay, positive, negative, doesn't matter. But they're all multiples of 3, so I'm going to divide them by 3. I have x squared minus 9 divided by 3 is 3x, minus 30 divided by 3 is minus 10. Now I have this 3, know that I'm multiplying to a negative, so I have a plus and a minus, a positive and negative multiplying to a negative. And I know because this is minus, so that's going to help me when I go through my fractions. Together to see if I can get 3. So negative 10 plus 1 is negative 9. That's not negative 3, so we're good. Negative 5 plus 2 is equal to negative 3. So that is good. Okay, so at negative 2 plus 3, or sorry, negative 5 plus 2. Negative 5 plus 2. So negative 5 plus 2 gets you negative 3. If I FOIL that out, I would go back to this, and then if I multiply the whole thing by 3, I would end up with my original 3x squared plus 9x minus 30. Okay, that's 11. Let's go to the whole thingy here. The next one I want to do is 16c, and the reason I want to do 16c was just because it's a 16c, n squared minus 36, 2 terms, negative, perfect square. Your perfect squares are 1 and 4 and 9 and 16 and kind of neat little thing. I do this in my class. Okay, there's 2 by 2. 2 times 2 is 4. There you see 4, 1, 2, 3, 4. 3 times 3 is 9, right? And remember this, guys. 10 by 10. 10 by 10 is 100, right? 100, we all know that. And then if I wanted to get 11 squared, well, I wanted to go 11. So if I had 10 by 10, I'm not going to do this, but if I had 10 by 10, I'd have 100 squares here. If I wanted to go 11, I would add a row there, that's 10 long, and then I have to add this row here to make this 11 long. Okay? So what happens is I go 10 squared plus 10 plus 11 is equal to 11 squared. And that's, let's just work that out. 10 squared is 100. 10 and 11, add those all up, and 11 squared is 121. And that is 11 squared. You can check the Google for that one. So 121, and so what's cool is those you might know, but let's say you don't know one, right? So let's say you have 20 squared. 20 squared is 400, right? But if you wanted to know what 21 squared was, so you'd have a box like this, 20 by 20, and you would add your 20 and you'd add your 21 to figure out what 21 squared is. So it's 20 squared, which is 400 plus 20 plus 21. Bam, 441. That's 21 squared. Pretty sure about it. I hope that's right. Otherwise, I just made a giant fool of myself. Where was I? Oh yeah, the DOS's. DOS. That's the gang Mr. Shaw was in back in his days. The DOS crew. Difference of squares. That's a perfect square. Okay. Usually we have x squared, n squared, that sort of thing. Sometimes you have a coefficient in front, but not usually. Then you have a negative, and then you have another perfect square. So that is equal to n plus the root of 36, which is 6, and minus the root of 36, which is 6. Everyone likes the DOS's. Don't forget these, though, okay? Again, don't focus on the hard stuff. Easy stuff. The last thing I'm going to do is section 2.5. This one is solved. Again, is it roots? Is it the x-intercepts? Is it solve? Is it the zeros? All the same thing, essentially. So I have 3p squared, and again the letters are. By that I mean, is it p or x or whatever. So can I common factor this? Can I take a 3 out? So complex trinomial, Australian method time. What you do is you take this guy and this guy, you multiply them together, and when you do that, you get minus 30. And we want two numbers that multiply to minus 30. Add 2, 18, 8, and I look around and I go, well, okay, there's 30, negative 1 is 30, negative 1. Those are factors. No. 9. So what's left? I don't know. 2, 2, 3. Yeah. So now I have 15 minus 2. How do I get 3p, and I put that at 3p. So it's this, but get rid of this square, just write 3p. And then over one of my numbers here is 15, and then one over negative 2. So I'm going to change colors again. Let's go brown. Or let's go with negative. And I ask myself, if this is a fraction, could I reduce this? And 3 and 15 are both divisible. 3, that goes in once, that goes in 5 times. And so that means that my one factor is p plus 5. This one here, 3 and negative 2, nothing, I can't reduce. So it's 3p. And those are my zeros. Sorry, those are my factors. So what are my zeros, or what are my... That's minus 5. And the other one we're going to do slowly here, but then before I leave you, I'm going to let's just pretend that 3p minus 2 is equal to 0. Well, let's solve for p. Not pretend. Let's solve for p if 3p minus 2 is 0. If we had that equation here, what we would do is we would say, okay, let's take that 2 over. So we're going to add 2 over this side. And then at the end, we're going to divide by 3. So p is equal to 2/3. And does that make sense? Well, let's go back here. If I went back over here, I had 3 times 2/3. 3 times 2/3. 3 times 2/3 is going to give me, what would that be? 3 times 2/3 is going to give me 6/3, which is 2. 2 minus 2 is 0, and that is right. Okay, so the answer p, so the answers here are negative 5 and 2/3. Let's practice them. Not so much of this, but mostly this. So let's go the one below. Now, this is not, this, I just made this up. So let's just pretend these are all our zeros, equal to 0, equal to 0, equal to 0. We're going to get our roots for all this. Okay, so we did all our factoring, and we're left with p minus 6 and 5p minus 1 here. Okay, so we want to get our zeros. Well, step 1, we can do it slowly, but let's not. Okay, the first guy is p minus 6. Just change that sign. My one root is 6. The next one, what I'm going to do is, what you did here, p minus 6, what you did here was you took this negative 6 and changed the sign. Same thing happens with the 1. So that becomes plus 1. Then you're going to divide by 5. Okay, you're going to divide by the coefficient in front of the p. So my two zeros here are 6 and 1/5. Those are my two roots. Now, if you say, why didn't I do that over here? Well, you kind of did. You just didn't really have to, right? You brought the 6 over, and then you divide by 1. That's the coefficient in front of the p. And that's 6. Now, we don't bother doing all that because you end up with the same answer as you did before. But let's practice a couple more. 3z plus 4, 2z minus 9. What are my zeros? Bring the 4 over, change the sign, divide by 3. Bring the 9 over, change the sign, divide by 2. Those are my zeros. Okay. Don't do this. Okay. No commas with the round brackets. Finally, let's go with this. I don't know. 6x plus 5 and, oh, actually, you know what? Let's pretend we had this, x and 6x plus 5. Okay? So let's add, 6x plus 5 and that. Okay, so if these are my two zeros, this guy, our practice is negative 5 over 6. Remember, don't make this too hard. When is done? And good luck, and that's it.